In example 2, we're going to solve this system and we're going to use substitution. So the substitution I'm going to use is for 2y. Since I see that there's a 2y here, and I also see that there's a multiple of 2y here. Okay, so I'm going to, first of all, solve for 2y. So I'm going to add 2y to both sides and subtract 17 from both sides. So I'm going to get 3x minus 17 is equal to 2y. And so there's my equation 1. And what I'm going to do on the right-hand side here is I'm going to rewrite this. 5x minus 7 is equal to negative 9 times 2y. And I'm going to rewrite that 2y in green, so 2y. And what I can do is I can replace the 2y that I have in the brackets with the 3x minus 17 because that is a like-for-like replacement. Since we have equality, we have like for like, and we can replace anything that's the same with itself. So I'm going to take equation number 2, and instead of using that 2y, I'm going to replace the 2y, just make sure I don't lose my equals here. I'm going to replace the 2y with an equivalent 3x minus 17. So I'm replacing a like for like, and what I've done at this point is I've eliminated one of the variables and I only have one variable left to solve for. So solving this system, I get 5x minus 7 is equal to negative 27x plus negative 9 times negative is positive. 9 times 17 gives me 153. Okay, so I did 9 times 10, 9 times 7, and added them together. So I'm going to add 27 to both sides. So here I get 32x. I'm going to add 7 to both sides. So I'm going to end up with 160 on this side. Okay, maybe I'll show the steps here. So I'm going to add 27x plus 27x plus 7 plus 7. Okay, the 0 pairs cancel out, 0 pairs cancel out, and I end up with 32x is equal to 160. Dividing both sides by 32, I'm going to end up with x equals 5. Okay, so that represents one solution. And then solving for y, what I can do is I can plug the x back into my equation 1. So instead of x, I'm going to replace that with x equals 5. I'm doing a like-for-like replacement. So then solving this, I get 15 minus 17 is negative 2 equals 2y. That makes my y value equal to negative 1. So those are my two solutions for x and y. In example 3, what I'm going to do is I'm going to make this balance here, just flip it around, and I notice there's a 3x that's same on both. So what I'm going to do is I'm going to put a 3x on, I have a 3x on the left-hand side over here, and what I've done is I've put a 3x on the right-hand side over here, and what that'll do is that allow me to cancel out the 3x's. So I'm just going to number my balances here. So this is number 1, this is number 2, this is number 2 here, and what I'm going to do is I'm going to add equation 2, so I get negative 5 is equal to 3x plus y. When I add those two equations, I end up with 3x minus 5 on the left-hand side. Here I end up with 3x plus, this is going to be 3y. Oops, 3x plus 1 plus 3y. Okay, so I've added I can't forget that 1 there. Okay, so this point, I now have a new balance. I've combined two balances, and I'm going to eliminate that. I'm going to eliminate the 3x on both sides, and I can do that because they are the same. It'll keep it balanced. And also by doing that, I've eliminated my variable of x. So now I have an equation with no x's. So I end up with negative 5 is equal to 1 plus 3y. Subtract 1 from both sides. I'm going to divide by 3. I get y equals negative 2. There's my solution for y. And again, I can solve for x by plugging back into either equation. So I'm going to take equation 2 here. So negative 5 is equal to 3x plus negative 2. That's what I've solved for y. I'm just going to highlight that. That negative 2 here came from this solution over here. Okay, and then I can solve for x. I'm going to subtract or add 2 from both sides. So I'm going to end up with negative 3 equals x. Sorry, 3x. And then I solve for x, divide both sides by 3. I'm going to end up with x equals negative 1. And there's my solution for x and y.